very important. Okay, let us start today with integration. So, integration is a very important part of mathematics, especially calculus. If you are doing +2 level and JEE, mains and advanced. So, I will give you first the introduction of integration. Suppose if I write, because we know derivative, dx of fx. Suppose I am writing fx. If you differentiate from fx, you will get small fx, some function, different function. So this fx is called the integral part. And this is the result of the differentiation. In mathematical notation, we write actually fx equal to integration. The symbol is actually integration plus some constants. This symbol is actually the integration symbol. This is actually s. S means sum. Sum. That means you are adding. And this s is elongated version is this s. This one. If you stretch s in the upper and the lower direction, it will look like an integration symbol. So suppose, for example, if I write whose integration is 2x squared, whose derivative is 2x squared, that is my question. Sorry. Suppose if I write dx of x cube is 3x squared, so if my question is whose derivative is 3x squared, your answer is will be x cube. So this x cube is the result of the integration. That means differentiation and integration are inverse process. Integration is the inverse process of differentiation. So if I integrate this one, I will get x cube. I will get x cube. So actually integration is the inverse process of differentiation. If my question is whose integration, whose derivative is this function, your answer will be by integration. Okay, clear? Divided?
Yes, sir.
Now the question is why this c? Why this constant? Why this constant? Now the question is why? Why are having some constant? Suppose what is the derivative of x or x squared? What is the derivative of x squared plus 1? What is the derivative of x squared plus 2? So how many functions are there whose derivative is 2x? How many functions are there? Infinite. So that actually we have to write, if you integrate this 2x, that we have to write in terms of constant. That is why the constant is there after the integration. Because there are infinite number of functions whose derivative is 2x. So usually what we do, if we integrate, we have to put a constant. That constants. That is why the constant c. In indefinite integration, this is what I am doing. Indefinite. What is definite? If you integrate within a limit, that is a definite. Suppose you are finding the area under the curve. This is fx. The curve is bounded between a and b. If you want to find this area, then your integration will be a to b fx dx. Actually, this symbol is integration sum. You are taking the sum from a to b fx dx. Okay, so that is why the integration is there in case of indefinite integration, but in definite integration there is no constant. Now let me give you some formulae first. I will give you some simple problems first that related to boards. After that we will move to some JEE problems. So I will give you a list of formulae for your better understanding. So I am writing fx, and this side you have fx integration fx dx. So I will give you some functions here and their integration results. So suppose first function is x to the power n. That integration of x to the power n is x to the power n plus 1 by n plus 1 plus c. That is the integration result. Why? Because you look at that your derivative of x to the power n plus 1 by n plus 1 is n plus 1 over n plus 1 into x to the power n. Look at that. So naturally, your integration of x to the power n will be this function. This is by integration. How will you write by integration? You have to write integration xn dx. That is x to the power n plus 1 by n plus 1 plus c. The integration result of x to the power n. Next, power n exponential function. Derivative of exponential function is the exponential function. So integration of exponential function will be exponential of plus some constant c. C is an arbitrary constant. And 1 by x, whose derivative is 1 by x? Ln log base e. So ln x. Now there are more. What is the a to the power x? Ln a cos x sin x minus cos x, because you see derivative of sin x is cos x, so integration of cos x will be sin x. Derivative of cos x will be minus sin x. Yes. Sec square x, that is tan x plus c. Clear? More I have cosec square x minus cot x plus c. Integration of cosec square x is minus cot x plus c. Sec x tan x. Sec x plus c. Cosec x cot x. Minus cosec x plus c. Tan x. Ln mod sec x cot x. Ln mod sin x one by root over 1 minus x square. That you can write sin inverse x or minus cos inverse x, because you look at that derivative of sin inverse x is 1 by root over 1 minus x square. So if you have this type of integration, directly you can write sin inverse x. Okay, or you can do it like this. You don't know the formula. You can do in a separate way. Suppose you have an integration. I will show you some integration also. 1 minus x squared. So let us substitute x equal to sin theta. So dx is equal to cos theta d theta, right? So that is cos theta d theta over 1 minus sin square is cos square theta. So that's one of the cos theta, which is theta plus c. And theta is nothing but I know sin inverse x plus c. Already you have a knowledge of inverse trigonometric functions. So that is the result. That we can do it. Or in JEE, we don't have much time. You can write it's some results. Yeah. Similarly, if you have 1 plus 1, 1 over 1 plus x squared, so it's gonna be tan inverse x, right? Or minus 40 inverse x. I will give you the full list of formulae first, because these results are required to solve problems. Secant log mod secant plus tan x plus c, or log mod tan of x by 2 plus 5 by 4 plus c. Cosec x ln mod cosec x minus cot x plus c, or ln tan x by 2 plus c. You have some standard integration. These are all standard integral results you can use for this type of functions. So writing this function as 1 by root over is just like this. 1 by root over x square minus x square, that is sin inverse x by a plus c. Number 2, these results are actually, you can use this one, you can use this one. Both the results have to be keep in mind, because you need some results in calculation. Maybe you have to do some identities. In that case, what is the identities you have to do in that? Accordingly, you have to use the problem. Yeah. 1 by root over x square plus minus x square, that is ln x plus root over x square plus minus x square. If it is a plus, you have to give plus. If it is a minus, 1 by x square minus x square, that is 1 over 2a ln 1 over a tan inverse x by a plus c. This is also standard 5 parts. I will go to the 5 parts question later on. Okay. So let me give you some problems. First set of problems, first 10 to 12 problems will be based on standard level on boards. So let me refresh those problems. Example 1. Evaluate power x plus 1 minus 5 to the power x minus 1 over 10 to the power x dx. Yes. How to do this? First of all, first step is split into two parts. That is 2 1 over 5 whole to the power x minus 1 over 5 into, that is 5 to the power minus 1 half to the power x, right? Yes. Okay. Now, what is the integration of a to the power x? A to the power x, integration of a to the power x will be a to the power x ln a plus c. So that's gonna be 2 1 by 5 to the power x over ln 1 by 5 minus 1 by 5 half to the power x over ln half. That's the result. That's the simple result. This is the integration result. Why this is integration result? because dtx of a to the power x is a to the power x ln a plus c. This is the derivative. So integration of a to the power x will be 1 over ln a x. Okay, very interesting chapter. Integration is very interesting, and some kind of brainstorming also. You have to apply some logic, some technique. In one problem can solve in many ways. This is not that kind of. There are many problems which can be solved for. And definite integration is more interesting because you will apply some knowledge of graphs also. Number 2. These are all basic. Okay. These are all basic problems. I have started from basic. I don't know what is your level. That is why I have started from basic problems. First, I will solve some basic problems. Evaluate sec square x cosec square x dx. Okay. So what I'm writing, sec square x cosec square x, you can write 1 by sin square x cos square x, right? 1 you can write sin square x plus cos square x over sin square x cos square x. So if you now split into two parts, that is your sec square x dx plus cosec square x dx. And what is the sec square x dx integration? Tan x, because derivative of tan x is sec square. And what is the integration of cosec square x? Minus cot x. So that is the result. That will be the result. Okay. Next, integration tan inverse root over 1 minus cos 2x over 1 plus cos 2x, 0 less than x less than pi by 2. One minus cos 2x by 1 plus cos 2x. So what is the formula for 1 minus cos 2x by 1 plus cos 2x? Multiple angles, tan square x. So what you are going to do? And tan inverse tan x is x, provided that x lies within this range. That is where the range is given. X dx. So that is x square by 2 plus c. Simple. Next, evaluate sec x over sec x plus tan x. So there are two ways actually for solving this problem. Either you can do multiply the numerator and denominator by sec x minus tan x. So that is your sec square x minus tan square x in the denominator, a plus b, a minus b, and sec square x minus tan square x is 1. So this is integration of sec square x minus sec x tan x. So sec square integration of sec square x is tan x minus sec x plus c. This is one of the way. Another way, or you can just simply convert it into sine cos. Yes. So sec is 1 by cos, sec is 1 by cos, tan is sine by cos. 1 by so I think dx by 1 over sine. Yes. 1 plus sine x. Yes. So multiplying the numerator and denominator by 1 minus sine x. If it is a plus, multiplying with negative. If it is a minus, multiplying with positive. So 1 minus sine square x is cos square x. So that is split into two parts. Sec square x dx minus sec x tan x. You see the same results will come. So there are two ways for solving this one. So next problem is dx by 1 plus sine x equal to the result is given in terms of tan and some constant b. So you have to find out a and b. You have to find out a and b. So look at the previous problem. The result was in sec and tan, but here you have tan x by 2 plus a in this one. So how to do this? How to do this? So basically, you are writing sin x as cos pi by 2 minus x, and you know from some multiple 1 plus cos x is 2 cos square x by 2, right? 1 plus cos x is 2 cos square x by 2. So that is dx over 2 cos square pi by 4 minus x by 2, right? So that is a half sec square pi by 4 minus x by 2 dx. So that is a half sec square is, what is the integration of sec square? Tan pi by 4 minus x by 2 over minus half plus c. Because what is the integration of sin mx or cos mx? So that is minus cos mx over m plus c. So what is the integration of sec square mx? You have some m. M is your minus half. That m should be divided by chain rule. Actually, you are integrating sec square mx. So sec square mx is basically tan mx over m plus c. That's it. So half of get cancelled minus. So you can write tan x by 2 minus pi by 4 plus c. So if you compare with this, your a is minus 4 and b is the arbitrary constant. Have you understood the point?
Yes, sir.
Okay. So let me write the next question. Yes, this one. So x plus 1 by x 3 by 2 and x square minus 1 by x square. So we can write this one as this form. So remember this and this. This form is very useful. So suppose if you substitute some z. So what is the derivative of x plus 1 by x? Derivative of x is 1 and derivative of 1 by x is minus 1 over x square times dx, and that gonna be dz. That means you are differentiating both sides with respect to x. If you differentiate both sides with respect to x, that is dz dx, and that I am writing in this form. Okay, clear? Okay. So you see, this part is your dz. Also, instead of x plus 1 by x, it's gonna be in some problems. It can be x minus 1 over. Then you substitute some key, and that is equal to 1 plus 1 over t square, 1 over x square plus. So that depends on the problem. So you are here, you have this. So it is z cubed dt dz. and that is equal to z to the power 4 over 4. Oh, sorry, 3 by 2. It is 3 by 2. 3 by 2 plus 1 over 3 by 2 plus 1 plus. Now it's 2 by 5. Yeah, 2 by 5 whole to the power. Your z is x plus 1 by x whole to the power 5 by 2 plus. Here, next, next is root tan x over sin x cos x dx. Root tan x over sin x cos x dx. So in case of trigonometric problems, trigonometric integration, your target is will be always sec square and tan in this form, because derivative of tan x will be sec square x dx. So if it is in this form and if it is a function of some function of tan x, any kind of function of tan x, then if you substitute tan x equal to c, then it's gonna be sec square x dx. Actually, you are differentiating both sides by x, so it is dz. So if it is a function of tan x and sec square x, with some manipulation, you can bring in the calculation some function of tan x and sec square x, then the problem will be solved by the substitution tan x equal to c, and because tan x is derivative is sec square x dx equal to dz. Actually, this is written as sec square x dz dx, and that is written in this form. So in this problem also, you have a mixture of tan x and sin x cos x. Tan x is already there, so you have to bring sec square x somehow. So let us divide or multiply the numerator and denominator by sec square x. Let us multiply the numerator and denominator by sec square x. So it is one cos is get cancelled and you have tan x. So it is tan x to the power minus half, right? Right. Now if you substitute tan x equal to z, sec square dx is already there. It's gonna be dz. So it's z to the power minus half dz. It's gonna be z to the power minus half plus 1 over minus half plus 1 plus c. Lastly, replace your z by tan x. That will be your answer. Okay. Next, dx over x square this one. This is a JEE type actually. Very good problem. Substitution, you require a substitution. Because if normal integration fails, you have to go for substitution or some manipulation. So here, my first target is to write 1 over something. So I will take this x to the power 5 outside the root. So x to the x squared, x cubed, 1 over x to the power 4, 3 over 4. Tell me, is that clear? I'm taking the x to the power 4 outside this bracket, and you are whole to the power 3 by 4, so it will be outside will be x cubed. 4 cancel. So it's 1 by x to the power 5. Now let us do the substitution. Always your substitution will be this complicated part because you have a root over there. So your substitution is this. And what will be your substitution? Your substitution will be 1 over 1 plus 1 by x to the power 4 equal to t to the power 4 something. Why I am taking the substitution t to the power 4? Because this fractional part will be removed and you have an integral part in the power. My target is to remove the fractional part. That is why I have taken the substitution in the form of t to the power 4. If you have 5, you will substitute t to the power 5. It depends on the denominator. Just my target is to remove the fractional part. So that is your minus 4 over x to the power 5 dx equal to 4 t cube dt. Right? So look at that. Look at that. You have dx by x to the power 5. Dx by x to the power 5. So if you do the correct manipulation, you will get the same. You will get the simplified form in the integration. So your simplified form will be t cube dt over t cube. Correct?
It means minus
Yeah.
integration of dt then.
T.
Yes, t, and then
Yeah.
substitute t equal to
No. Yeah. So your integration will be t plus c. What is your t? Minus 1 plus 1 over x to the power 4 whole to the power 1/4. Because if your t to the power 4 is this, your t is gonna be 1/4. Okay, so these are all simple problems, not very complicated one. It's a level 1 type of problem. Level 1 type of problems or mixed problems of substitution and simple problems of integration. Basically. Now I will move to by parts. What is by parts? First I will explain. Integration by parts. Integration by parts means actually there are integration of two functions, ux and vx, product of two functions. Actually, there are product of two functions, ux and vx. Two functions product and how to do this integration. We can integrate. So one of these is the first function and second function. Let me write this is the first and this is the second function. So first function constant fixed integration of the second function minus derivative of the first function and the same integration on the result you integrate. On the final result you integrate. Once again, if you have two functions, you will keep one of the function as first function, another one is second, but there is a rule for doing that. I will let you know. So first function is fixed, integration of dx dx minus whichever function is fixed, derivative of that function, and the same integration you are doing here, and on the result you have to integrate lastly. That will be give you the result for by parts or integration result plus some constants. Now what are the criteria for choosing first function and second function? That is sometimes given by LECTURE or sometimes I limit in this form. So what is L or I? I for inverse, L for log, A for algebraic, T for trigonometric, E for exponential. So suppose you have a mixture of I and T or I and algebraic. So your inverse will be first function. Who comes first? That will be your first function in this format. Order of choosing first function. Whichever function comes first in the order, that will be your first function. So suppose there is a combination of L and trigonometric. L will be your first function. Because you don't have a formula for integration of log, but you have a differentiation for all the functions. You can differentiate all the functions. Right? So this is the criteria. Suppose, for example, I'm just giving you one example. Suppose you are integrating x log x or simply log x first. I'm just integrating simply log x. How will you integrate? Because there is an integration formula for log. So log into 1, suppose your algebraic polynomial, 1 is a constant polynomial. So your first function will be log according to this L and A. L comes first, so log will be first function. Integration dx minus derivative of log x 1 by x into this integration. Correct? Actually ln x. So this is x. Integration of dx will be x. X cancel.
X log x.
Plus C is an integrating constant. So that is the use of by parts rule. That is the use of integration by parts rule. That is the use of integration by parts rule. Am I clear, Deepak?
Both Liat and Nyland.
Anything, because this is the same. Only thing is that L and I cannot be together. So there is no question of.
Understood, sir.
Okay.
So either there will be L or there will be I.
Either
With
you
A.
can follow this and this, no problem.
Okay.
Because there will be no problem having log and inverse together. And that is not, you cannot solve by general. That cannot be the problem of your interest. Another problem, if I give you, try this one. Suppose x log x. What is your answer? Tell me. Okay, here you have, this is your algebraic, this is your log. So log will be the first function, right? And integration of x minus derivative of log x is 1 over x into this integration. I am taking it directly. That's gonna be x square by 2, and on the result you have to do the integration with respect to x. So that's gonna be x square by 2 log x minus x get cancelled. Half again you have x integration x square by 2 plus. That will be your expression. Okay. Another problem, suppose. So I'm doing some by parts simple problems. Suppose you have sine inverse x, inverse function. There is no integration of inverse function.
No.
You have derivative for inverse. 1 by root over 1 minus x square. But you don't have a integration result.
Like
Okay, so what we can do? We can simply do 1 into sine inverse x. Sine inverse x is the first function. Minus derivative of sine inverse x is root over 1 minus x square. And this integration will be x dx, right? Okay. That is x sine inverse x minus, for this integration you have to substitute. What is my substitution? I told you your substitution will be to remove the fractional part in the denominator. What is your fractional power? Half. So my substitution is z square. If your fractional power is 1/4, z to the power 4. If your fractional power is 1/3, z cube. So here you have 1 over 2. So z square. So that will be minus 2x dx equal to 2z dz, right? So you have x dx, c and 2 to cancel. You have x dx, right? So that is plus z dz over z, because 1 minus x square is z square. So root over z square will be z. Integration of dz will be z, and z is root over 1 minus x square plus c. Okay. Another way. I'm just giving you all the possibilities. I'm just giving you all the tricks gradually. I'm just gradually increasing your concept. So what we can do next? Next is, suppose I am substituting sin inverse x is equal to theta. So x is equal to sin theta, right? And what is your dx? Dx is gonna be cos theta d theta, right? So this is equal to theta cos theta d theta. Tell me, have you understood? Because sin inverse x is replaced by theta and dx is replaced by cos theta d theta. Now your algebraic and trigonometric. Which one is your first function? Algebraic. So theta is gonna be the first function. So cos theta d theta minus derivative of theta is 1. What is the integration for cos theta? Sin theta. So it's theta sin theta minus, what is the integration of sin theta? Minus cos theta plus c. So see, you can replace your theta by sin inverse x and sin theta by x. So your result will be x sin inverse x and cos theta will be root over 1 minus x square. See, you are getting the same result but in a different technique. We can use the substitution initially also for inverse function. Okay. Next is little bit difficult problem and good problem actually. Evaluate sin inverse root over x by a plus x dx. Okay, let us substitute in this problem. You have to substitute this part. Let us substitute x equal to a tan square theta. Why I am substituting this tan square theta? Look at that. Look at your denominator. If your denominator is something like plus, then your substitution will be tan square theta. Because 1 plus tan square theta is x square theta, the root will be 0. And if your denominator is having minus, then your substitution will be sin theta or cos theta. Because 1 minus sin square theta is cos square theta, or 1 minus cos square theta is sin square theta. So with that observation, you have to select the substitution. So if you substitute this, it's gonna be, because first you have to simplify this part, otherwise you cannot integrate. So a tan square theta over a common, if you substitute 1 plus tan square theta is sec square theta. So a sec square theta. Oh, your dx will be the derivative. Derivative will be 2 tan theta sec square theta d theta by chain rule. Derivative of tan square theta is 2 tan theta sec square theta. So it is 2a sin inverse. So it is sorry 2a right here, replacing your dx. Replacing your dx also. Replacing your dx also. 2 tan theta sec square theta d theta. So this tan square by sec square, that is sin theta. A got cancelled, sin square theta, that is sin theta. Sin inverse sin theta into tan theta sec square theta d theta. That's gonna be 2a theta. So this is the simplified form. Now you observe, your observation will be there are two functions actually. One is theta, another one is trigonometric, that is tan theta sec square theta. So let us, this is algebraic, this is trigonometric. So let us suppose your first function as theta and tan theta sec square theta is the second function. So I will apply by parts now. Let me apply by parts now. So 2a theta first function. You see the integration is tan theta sec square theta minus derivative of theta is 1. Again you have integration tan theta sec square theta d theta whole d theta. Now let's come here. What is the integration of tan theta sec square theta? Can you tell me? If you substitute tan theta z sec square theta dz, right? So it's gonna be z dz, right? So it's z squared by 2 plus c. That is a simple integration. So tan square theta by 2. So I'm writing here directly without showing this, just calculate it in the space. So you have 2a theta tan square theta over 2 minus, it's gonna be tan square theta. Clear? Am I clear up to this? So it will be a theta tan square theta, but there is no integration for tan square theta. Oh, 2a is multiplied here also. So so tan square theta I'm writing sec square theta minus 1 d theta. Now you have a result for sec square theta. Integration for sec square theta will be tan theta minus theta plus theta. Lastly, you have to convert all. So I'm writing a theta tan square theta minus a tan theta plus a theta plus c. What is your substitution? Your substitution was x by a tan square theta. So tan theta is root over x by a, theta is tan inverse x by a. Okay, what is your tan square theta? X by a minus, what is your tan theta? Root over x by a. What is your theta? Tan inverse root over x by a. That's it. That is your conversion. Here you have a, yeah. That's it. Okay. That was a good problem, very good problem, and very standard problem actually. Inverse integration of inverse requires a knowledge of 5 parts. Maximum problems will be solved by this. Next, I will use by parts, but with some cancellation. Suppose you have exponential function into fx plus f prime x, that is derivative. Then if you write in this form in integration, then your result will be e to the power x fx plus. This is your answer. This is your answer. So how to prove this one? Let me prove this part. So let me by parts on this. Let me split into 2 parts. Exponential function, and you have some function. So let me write fx as the first function, exponential as the second function, minus f dash x into e to the power x dx plus e to the power x f dash x dx. You look at that, this is cancelled, and you have the result. Okay. So using this, just try this one. E to the power x 1 over x minus 1 by x squared. Actually, this is nothing but your right.
Yes.
The differentiation 1 by x will give you minus 1 by x squared. So nothing to calculate because already proved here. So your result will be simply one step solution. A beautiful problem. If you can identify some problem. So I will give you some kind of thing. This is a very simple thing. This is by parts with cancellation. You will get quickly results for that. Okay. So suppose e to the power x 1 minus sin x by 1 minus cos x dx. Right. So what is your submultiple? Right. Submultiple. Sin x I am writing 2 sin x by 2, cos x by 2 and 1 minus cos x and 2 sin square x by 2. Okay. Okay. Correct. What is the derivative of cot x by 2? Minus cos square x by 2 into half. So look at that. Here. And basically today doing whatever we have done today, basically on level 1. Because without this knowledge, you cannot solve some problems, especially very difficult. Next is log x over 1 plus log x whole square dx. So let yes equal to some t. No, let log x as t. So x is e to the power t. What is your dx? Right. So let me replace correct. T plus 1. So I am writing t plus 1 minus 1 in the numerator. Correct? Split. Right? So look at that in the form. So your result will be this one. Clear? I will write more results on this and I will show you by parts also. Partial fractions. Partial fractions. So suppose you have a in integration you have a functions like this. Rational functions this is called. And this is sometimes called proper fraction if the degree of px is less than qx. So degree in the numerator is less than the degree in denominator. That means denominator having the more power than the numerator. Then that type of fraction is called proper fraction. In case of rational functions. Otherwise it is improper. Okay. Now there will be three cases. Now these qx have different factors. There will be three cases for that. Number one, these factors of qx are number one, linear and non-repeated. Number two, linear and repeated. Number three, quadratic. Quadratic and non-repeated. Okay, what happened? Linear and non-repeated. The factors of qx are linear and non-repeated, linear and repeated, quadratic and non-repeated. So suppose your qx will be in the form x minus a1, x minus a2, x minus a. In this form. So in this case you have to assume a1 over x minus a1, a2 over x minus a2, etc. plus the last one. This constant, this is by you are writing px by qx as a1 by x1 x minus a1, a2 by x minus a2, and an by x minus a1. A1, A2, An are to be determined by equating the like powers of x or by the substitution. I'll show you. Okay. So if you look at the factors are not non-repeating and linear, then you have to assume this. If it is linear and repeated, Suppose your qx will be in this form, x minus a whole to the power k and some of the factors of x minus a1, x minus er. Then in this case, you have to write px over qx by a1 over x minus a2 over x minus a whole square, because it's k through k times, repetition is k times. And so you are writing ak by x minus a whole to the power k, and the others you can write as a similar b1 by x minus a1, etc. So if there is a repetition, you have to write px by qx in this form. Again, a1, a2, ak, b1, b2, etc. are constants, are to be determined by equating the like powers of x or by the substitution. Okay. Now the last case, quadratic and non-repeated. So if you have a quadratic, suppose qx is, so what will be then? You have to write ax plus b over ax square plus bx. These a and b are constants, again to be determined by cross multiplication, by equating the like powers of x from both the sides or by substitution. I'll show you now some examples on that. So I will show you some problems on partial fractions. First problem. X minus 1 over x minus 1 x plus 2 into x minus 3. This is clearly rational functions. Proper or improper? Degree in the numerator is 1, degree in the denominator is 3. It's a proper fraction. So, and the factors are like this, no repetition, linear and without repetition. So you have to assume a over x minus 1 plus b over x plus 2 plus c over x minus 3. Am I clear? ABC has to be determined by equating the coefficients. So let me now cross multiply. I'll show you two ways. After the cross multiplication, right? Okay. Now first method. By comparing the like powers of x. Method 1. By comparing the like powers of x from both the sides. So what is your, on the left you have a linear. So what is the coefficient of, on the right you have the x square and you have x square if you multiply. And on the left you have no x square term. So on the left you will write 0. That means I am equating the coefficient of x square. On the right, what is the coefficient of x square? A plus b plus c. Am I clear? If you expand, what is the coefficient of x square in the first term? A. What is the coefficient of x square in the second term? B. What is the coefficient of x square in the third term? C. So what is the combined coefficient of x square? A plus b plus c. And what is the coefficient of x square here? No term of x square, so it's 0. number 1, equation number 1. Now I will equate the coefficient of x. Coefficient of x is 2 on the left. What is the coefficient of x? Minus 3a minus 3 plus 2. So minus a minus 3b minus b minus 4b, and you have 2c minus c plus equal to. Am I clear? And the constant term is minus 1. What is the constant term here? Minus 6. It is minus 1 on the left, and you have minus 6a plus 3b and minus 2c. So solving this simultaneously quickly, you will get a, b and c. After getting a, b, c, you can integrate this as 1 by, this is a constant, so it's a dx by x minus 1 plus b dx by x plus 2 and so on. What is the integration of dx by x minus 1? Log mod x minus 1. ln dx by x is 1 and what log x, also dx by x minus 1 is log x, dx by x plus 2 is log x, dx by x minus 3 is log x. Whatever be the constant, no problem, because if you substitute x minus 1 and z, that's gonna be dx equal to dz. So dz by z, the integration will be log. Clear? Now this is method 1, but method 1 takes much time. Calculation is huge sometimes. So let me give you a very tricky and the easiest method to find out the values. That is method 2 by the substitution. Actually, you have to substitute here. You have x minus 1, right? So I'm substituting here x equal to first I will substitute x equal to minus x equal to 1. Substituting x equal to 1 on both the sides. You have 2 minus 1, 1. This is your 3 minus 2, 6a, right? Minus 6a. Is it minus 6a? Yes. So what is the value of a? Look at that. You are getting minus 1 by 6 times. What is the next value? Next value is minus 2. Let me write minus 2. This is 0. The other terms will be 0. These terms will be 0 if you substitute x equal to 1. If you substitute x equal to minus 2, this term will be 0. This will be 0, but you will get this. From here, you will get b. What is your minus 2 if you substitute? Minus 4, minus 1, minus 5. Minus 5, and this is 0. Here you will get the value. So minus 2, minus 3, and minus 5. So 15p, right? Minus 1/3. P is minus 1/3, right? Look at that, you are getting directly minus 1/3. Similarly, last case, x equal to 3. So if you substitute x equal to 3, you will have 5, 3, this is 0, this is 0, but you will get
5 equal to 10.
5 equal to 10c. Okay, fantastic. So c is gonna be half. So you will get lastly half into dx by x minus 3, and you will get the result of integration directly and very quickly. So this is the easier one, right? Easier one to calculate. Now in the problems, how will you write directly? I will not show this one. In the JEE problems, if I have partial fraction, then I will write like this. This is your thing. This. So I will write. Yeah. So I will write this directly. This directly. I am writing. First, I will write 1. So it will be 1 over x minus 1 into 3 into minus 2 plus next I will substitute minus 2. So minus 2, it will be minus 5, right? By minus 5 minus 1 x plus 2. I will not substitute x plus 2 because it will be undefined in this case. So in this case, you will have minus 2 minus 3. And the last one, I will substitute 3. So 6 minus 1 by 3 minus 1, 3 plus 2 into x minus. You will get answer. See, you have only variable x minus 1 by 1 minus 1 by 6 x minus 1. So that is minus 1 by 6 log plus this is your 1/3 now. ln x plus what is your last one?
1 by 2
Plus this is your plus. So that is by partial fraction, and this is the quick method. Okay. Another problem. Some kind, suppose dx by you have some x plus 2 and you have x plus 3 whole square into x minus 1. This type of. So in proper fraction, your degree in the denominator more than the degree in the numerator. So it's the proper. So let me write the function, and there is a repetition. Have you seen the repetition term? So x plus 2 let x minus 1 into x plus 3 whole square, that is a by x minus 1 plus b by x plus 3 plus e by x plus 3 whole square. So if there is a repetition, I will repeat like this and do the same process by putting the coefficient or by the substitution. You can get the values of arbitrary substitution. You can get the values. Okay, so that's all for today. So basically today is the level 1 problems, but a lot of techniques and formulae we have developed before going into level 2. Okay.